Here is a demonstration or example for a simple parallel circuit. First thing we're going to start with is the equivalent resistance. Now, equivalent resistance in this case is the inverse of the sum of the inverses. So it's 1 over the equivalent resistance is equal to 1 over 2 plus 1 over 3 plus 1 over 4. And you can put this into the calculator, or you could just use the lowest common denominator method they teach you in math class. For 2, 3, and 4, the lowest common denominator is 12, i.e. each of these is a factor of 12. So I do 6 over 12, 4 over 12, and 3 over 12. Each of those would reduce down to what you see above. So that gives us 6 plus 4 plus 3 is 13 over 12. Not done yet. I need to take the inverse of that sum. So 1 over RQ is equal to 13 over 12. That inverse is going to be 0.923. Alright, next thing. From this, I can now go ahead and work through the total current using Ohm's law. Ohm's law says I equals V over R. So if we're going to do 12 divided by 0.923, we get 13 amps. Now, to figure out each of the currents across each path, I'm going to use Kirchhoff's loop rule. You could do it other ways, but this will work. So for the first loop, right here, we got, and remember, the loop rule says that the sum of the voltages around a path is 0. So it's not around the circuit, it's around the path itself. So for this first path, it is just one resistor. So it's 12 minus that current, I2 times 2, that equals to 0. Rearrange that, and so you get 12 minus current times 2 equals 0. Solve for current, and you get 6 amps. So we're going to do that for each of the other paths. We're going to do, here's 2, and here's path 3. Okay? So we go 12 minus I3 times 3, and that will give us 4 amps. For the final one, we're going to go ahead and do 12 minus I3 times 4, and that will give us 3 amps. So let's go ahead and do a double check. Well, first off, double check would end up being that when we add all of these up, you notice that it equals the one we got using Ohm's law. So it works. I'm also going to discuss it to you with you in terms of Kirchhoff's junction rule. Okay. So Kirchhoff's junction rule would say that, let's go ahead and put our currents in here. Okay, so we got I1, I2, and I3. So we're going to start up here at the top, right here. So coming into this point, we've got 3 amps. It's going to meet up with this junction, and that's 3 amps plus 4 amps, that gives us 7 amps. So that 7 amps now moves on, adds up with the 6 amps, gives us 13. So that 13 comes into the batteries. There's no change over the battery. We have 13 coming out the other side. Now watch what happens here. So 13 comes up, it hits this junction, and it splits. We have 13 and splits, and there's 6 going here. So 13 minus 6 is equal to 7 amps. 7 amps hits this junction, splits, and now it's 7 minus 4, and that gives us 3 amps, and that's right back where we began. So that's really how the junction rule works. So we've got all of our currents in. We've looked at it like 3 different ways. We looked at it from the loop rule, we looked at it from the junction rule, and we looked at it from Ohm's law. Now let's take a look at the voltage. Now we'll do this 2 ways here. So basically voltage, we know that in voltage, as you move across the path, alright, the voltage drop across each path is the same in a parallel circuit. You can double check this with Ohm's law, because, well, alright, so these are 12 volts, means they're all the same, 12 volts, 12 volts. If you want to double check it, use Ohm's law, V equals IR. 6 times 2 is 12. 3 times 4 is 12. 3 times 4 is 12. So Ohm's law works as well. Next up, all we got to do is we're going to use power is equal to current times voltage. We're going to do that for each one of these. 12 times 6, 72. 12 times 4 is 48. 12 times 3 is 36. And 12 times 13 is 156. These are all watts. Double check for this one is that the P total is also equal to this sum of the individual powers. So P1 equals P2 plus P3, and if you add 72, 48, and 36, it will equal 156. That is how you do a parallel circuit.